The rubber compound is the basis, and its formula is naturally a closely guarded secret. However, in just a single tire, several different rubber compounds are used. So for the carcass, sidewall, tread section, and puncture protection layer, specifically developed mixtures are produced. The base mixes are rolled out into thick slabs called skins and temporarily stored before subsequent processing. The extruder combines different rubber mixtures under enormous pressure. A triplex extruder can combine 3 rubber mixtures, for example, center tread, shoulders, and sidewalls. A unique endless strip is produced for each kind of tire, cooled, checked for regular weight, and laid up in rolls. The carcass, essentially the tire's backbone, begins here. A dense nylon fabric is rubber-coated, absolutely evenly and as thinly as possible on both sides, in order to achieve an optimal tire weight and in addition to ensure that the tire is perfectly balanced. The coated fabric is cut at a 45-degree angle and then rejoined. Only by applying this angle in the rotational direction can the carcass give the future tire the necessary stability. All of the pre-prepared materials are now combined to form individual tires. This is highly labor-intensive work, not surprisingly assisted by state-of-the-art machinery. The carcass is laid up, cut, and joined. Then the wire beads are inserted and covered by the carcass. The 45-degree threads of the carcass material now lie on top of each other, forming a tire that has a diagonal structure. With folding tires, instead of wire, a flexible aramid bead is inserted. In this operation, the appropriate puncture protection layer is inserted. These centering lasers are used in all build steps to precisely position the materials. Additionally, the tire bead gets a further protection layer. As the last build step, the tread is applied accurately to the center of the tire. Here, a bicolored racing cycle tire for competition use. Finally, for quality control, each tire blank is marked with a stamp of the individual tire builder. Each tire now has its name and brand label applied. Additionally, many also have reflex strips applied for enhanced visibility in traffic. This so-called green tire still has a soft consistency and doesn't have a tread. At this point, the chemical process of vulcanization takes place that will transform it. But first, a heating tube is inserted inside the raw tire. Finally, it is ready to be vulcanized in the tire press, like a giant waffle iron at around 170 degrees for 5 to 6 minutes. After each cycle, 6 tires with their special Schwalbe treads are born. As the tire now has its flexible characteristics, only after vulcanization is it possible to describe it as rubber, precision manufactured, and are responsible for the tread. Naturally, they also irreversibly stamp the brand name. At the end of the production process, strict quality control awaits each tire. Tire by tire, they are taken for careful inspection. Permanent random sample checks are made of weight and for runout. Only in this way can we ensure that daily, many thousands of only the highest quality Schwalbe tires leave the factory. The inner tube is made in a similar way to the tire. The base material is mixed, kneaded, and stored temporarily as skins. Besides the high butyl content, and at only 1 millimeter thick, crucial to the airtightness of the strong Schwalbe tubes is the purity of the material. The base material therefore has to be pushed at enormous pressure through 7 filters, and thereafter it is extruded as a continuous tube. The individual tube is cut to length, then the valve is placed over the pre-punched hole. The tube ends are accurately pressed, one onto the other. On impact, they join immediately because the raw material is still sticky. The tubes are lightly inflated and then vulcanized in the same way as the tires, though of course without a tread. All tubes are inflated and are stored for 24 hours in order to test that they are airtight. Afterwards, each individual tube is carefully checked by visual inspection. Random samples are taken and examined for air leaks and weight. Now each tube has to be completely deflated in order to ensure compact packing.